Welcome to Laws of Indices Level 1. Pause the video now, try the 5 problems on the screen, and I'll go through them with you shortly. You'll find more practice at this level, plus links to the higher levels, as well as other topics, at the end of this video and on the channel homepage. In problem 1, we're simplifying 48b cubed divided by 6b to the power of 10. Now, since we're dividing indices here, we're going to use this law, which tells us that when we divide indices, we subtract the powers. So starting with 48 divided by 6, we have 8, and b to the power of 3 divided by b to the power of 10 becomes b to the power of 3 minus 10, using our law. And since 3 minus 10 is minus 7, our final answer for this problem is 8b to the power of minus 7. In problem 2, we're simplifying 12a to the power of 9 multiplied by 5a to the power of 6. Now, since we're multiplying indices here, we're going to use this law, which tells us that when we multiply, we need to add the powers. So starting with 12 times 5, that gives us 60. And a to the power of 9 multiplied by a to the power of 6 becomes a to the power of 9 plus 6. And since 9 plus 6 is 15, we have 60a to the power of 15 as our final answer for problem 2. In problem 3, we're evaluating 3t to the power of 0, and this means we need to find its value. Now, since we have a power of 0 here, we're going to use this law, which tells us that anything raised to the power of 0 is equal to 1. So this means that t to the power of 0 is equal to 1. And so 3t to the power of 0 is equal to 3 times 1, which is 3. So our final answer for problem 3 is 3. In problem 4, we're simplifying 45r to the power of 8 t to the power of 5 over 9r cubed t to the power of 4. Now, since this fraction means that we're dividing the numerator by the denominator, we're going to use this law, which tells us that when we divide indices, we subtract the powers. So we can start with 45 divided by 9, which is 5. Then moving on to the r's, we have r to the power of 8 divided by r to the power of 3. So we have r to the power of 8 minus 3, using our law. And t to the power of 5 divided by t to the power of 4 becomes t to the power of 5 minus 4. Now simplifying, we have 5r to the power of 8 minus 3, which is 5. And 5 minus 4 is 1. So we have t to the power of 1, or just t. And this is our final answer for problem 4. In problem 5, we're told that q to the power of n multiplied by q to the power of 7 is equal to q to the power of minus 3, and we need to find the value of n. Now, looking at the left-hand side of the equation, we're multiplying indices together, so we're going to use this law, which tells us that when we multiply indices, we add the powers. So this means that the left-hand side becomes q to the power of n plus 7, and the right-hand side is just q to the power of minus 3. Now, since both sides of the equation have the same base, which is q, this means that their powers must be equal to each other. So n plus 7 must be equal to minus 3. So to find the value of n, we now just need to solve this equation. And on the left, we need to remove the plus 7. So we use its inverse, which is minus 7. And we do the same on the right. Going back to the left, 7 minus 7 is 0, so that just leaves us with n. And on the right, minus 3 minus 7 gives us minus 10. So our final answer for problem 5 is n is equal to minus 10.